Greetings, human anatomy students. Today we begin to look at the digestive system, and here's a little video clip of Cookie Monster and his relationship with cookies and veggies. If you're interested in watching that, but first I want to begin by taking a moment and just see if you can identify each picture as either food or not food. And bear with me, I realize this sounds ridiculous. So a brick, obviously not food. An apple, obviously food. Um, but what about applesauce? I think we would still say, yeah, that's food because you're taking the apple, you're chopping it up, you're heating it, you're kind of adding some additional ingredients to kind of make it nice and yummy. Definitely still food. But then all of a sudden, we go to Mott's applesauce where there's maybe some additional chemicals added in for preservative purposes and things like that. Or Apple Jacks, where even more sort of strange things are added to it. Or a Apple Sour Patch Kids, where maybe, yeah, there's some sugar in there, and yet there's even more kind of weird stuff added. And so, an interesting question is, where do we draw the line between what you'd consider a natural, healthy food source and something that maybe isn't quite fully food, but rather some other concoction? Or another way to think about it, our ancestors, if we were to go back to early humans and just kind of put them into a grocery store, what would they actually recognize as food, and what would they look at and think, what the heck is this? There's a great TED Talk that sort of talks about America and our relationship with food. And I normally do show this in class, and I'd really encourage you to pause and watch it because it's kind of thought-provoking and kind of ask this question, what is food and what is not food, and what do we eat and why do we eat that? And it's a really good thing to, I don't know, check it out. You'll like it. Anyway. I kind of like when in asking this question, I really like Michael Pollan as an author, and I think he's done a good job. And his dietary advice as we struggle with, what should we eat, what should we not eat? His main dietary advice is timeless and really is something that's going to hold up forever, unlike a lot of fad diets. And his three pieces are eat food, and he would characterize food as things on the apple and applesauce spectrum. So things that don't have a lot of added chemicals and strange ingredients added. Not too much. Which is certainly a problem here in the United States. Many of us eat more than we need, and mostly plants, because plants, frankly, are healthier than meat, better for your body, better for the environment. And that's kind of it. So if you're looking for just kind of general guidelines that will stick with you, I think this is kind of a good approach to eating. And if you want more, here are two great books that he's written that kind of looks at this. So you can check those out if you want. Okay, so the digestive system. Quick overview. The main function of the digestive system is that it provides raw materials for the body, such as carbohydrates, fats, and proteins. And you may remember in biology, you studied each of these ingredients, each of these components at the molecular level, and you studied them because they are the stuff of life, and they're the stuff of life, and therefore we need to eat them to keep our bodies, which are life, going. In addition to those, we also need vitamins, and vitamins are organic molecules needed in small amounts by the body. So, organic means they're carbon-based, so every little junction represents a carbon atom. Organic molecules have this kind of general structure. We've kind of talked about some of these. You may remember folic acid is recommended. It's recommended that pregnant women get a lot of folic acid because that helps babies develop, and if you don't have enough folic acid, you can get spina bifida, which is where your spinal cord in the baby kind of bulges outside the body, and that's obviously problematic. We've talked about vitamin A as a component of vision. That's what helps absorb the light in the retina. So we've talked about these, and again, they're just needed in small amounts for particular chemical reactions or for particular processes. And there's vitamin A in vision as a component of those rod and cone cells. Minerals are very similar. They are also needed in small amounts by the body, but in this case, they are inorganic substances. So these are inorganic ions needed in small amounts by the body. So like anything on the periodic table, sodium ions, potassium ions, calcium ions, magnesium ions. So here's some minerals that we need to take in for our body. And again, I'm hoping you kind of remember why we need some of these. Sodium, potassium, these came up in this class. What do we need these for? Say it. Action potentials, right? So to send signals to the neurons, sodium rushes in, potassium rushes out. So we need sodium and potassium in our body so we can carry out that process, and we get those sodium and potassium ions from our diet. Calcium, where do we use this? There are a couple places. Many of you are probably thinking bones. Calcium's in our bones, and you're absolutely right. But don't forget about muscles. Calcium, remember, is what binds to troponin, which moves tropomyosin out of the way, which allows that little myosin head to grab on, and that's what makes that sliding filament thing go on. So calcium is needed. Iron, do you remember we saw iron? Iron, hemoglobin. So this is what's used to carry oxygen throughout the body. So the digestive system is where we get all these raw materials. We get it from our food, and we need these things for just day-to-day functioning. The other major function of the digestive system, though, is that it provides fuel for cellular respiration. So you may recall this equation came up when we looked at the cardiovascular system. We said the cardiovascular system is responsible for bringing oxygen to our cells and removing carbon dioxide waste from our cells. Well, the digestive system is all about the fuel. It is what brings in the glucose or other things like fat or more complex sugars that can be broken down to glucose to be fed into this cycle. So it provides the fuel we need as well. Now we're going to have a little spogle activity in here somewhere, but I'm just going to skip over that for purposes of that screencast. And that spogle, you're going to kind of look at a lot of these same ideas and have a chance to kind of process those and think them through. But a couple terms that come up. One, the alimentary canal is simply the long tube of smooth muscle that runs from mouth to anus. And so here's a funny picture that's not real, it's fake. But the general idea is you have this continuous tube from your mouth to your anus. And if light could kind of turn those corners, this would actually be able to happen. It's one long continuous tube. And so when you put food in your mouth, it's technically not really in your body yet. It's just in this tube that runs through your body. And any nutrients you want have to be pulled into the bloodstream, and any waste products that you don't have any need for just continue to pass through that tube and come out the other end in a very disgusting fashion. Accessory organs, on the other hand, are organs that help in digestion, but food doesn't pass through them. And we're going to see lots of examples of these. Spoiler alert, the liver, the pancreas, the gallbladder, salivary glands, even your teeth are accessory organs. Another couple pairs of terms that are going to come up throughout are mechanical versus chemical digestion. Mechanical digestion is where food is just physically broken down into smaller pieces. There's no chemical reaction that's happening. Chemical digestion is where there's a chemical reaction. Molecules are broken down into smaller molecules, typically by enzymes. So a big complex carbohydrate is broken down into simple carbohydrates, or a big complex protein is broken down into the building blocks of proteins, which are amino acids. So that's chemical digestion. Mechanical is just kind of where it's kind of chewed up in your mouth, for example, by your teeth and things like that. Okay, so now it's time to eat. We're going to have a little bite of this sandwich. There's butter on this sandwich, and so we're going to track the bread, which is mostly carbohydrate, the ham, which is mostly protein, and then the butter, which is mostly fat. And we're going to see what happens to each of these components as food moves through our digestive system. So, as we all know, food begins its journey in the mouth as you take a bite. This guy, I don't know, that look on his face has always been kind of disturbing to me. He's a little too into that apple, if you ask me. But anyway, he's going to take a bite out of that apple, and let's take a look at what happens. So the first structure that we're going to look at today are the teeth. Now, the teeth are an accessory organ. And their job, as I think you're aware of, is to break food into smaller pieces. So is that chemical or mechanical digestion? Think about it. Think about it. Say mechanical? I hope you said mechanical. It's mechanical digestion because it's breaking the food into smaller pieces. You have, there are 20 primary or what are called baby teeth and 32 permanent teeth. So you have 32 teeth. Of those, four on the bottom and top, so actually eight incisors. You have canines, two on the bottom, two on the top. And then you have what are called premolars and molars. All of these look the same, and you might wonder, why do we have different names for these? Well, look at these numbers, 20. Check it out. There's four incisors, two canines, that's six, four premolars, that brings us to a total of 10 teeth, times two, because this is on the top and the bottom. That's where you get your 20 baby teeth. So you actually have baby premolars. The molars come in later. You don't ever have these as a baby. They just develop later. And then you get 3 plus 3 is 6, times 2 is 12. That's where you get 32 permanent adult teeth. So you actually get these as bonus ones later. So the incisors are really there for biting. They're kind of like this. They kind of shear the food like a scissors. You bite. The canines are kind of pointy, and they're used for tearing into meat and things like that. The molars, if you just feel your molar, the back teeth in your mouth with your tongue, you'll notice that they're kind of ridgy and bumpy. They're used for grinding the food down. And that rough, complicated texture helps kind of crush things and things like that. So check out this kid's canines. You can see these really pointy canines. That's me, by the way. I think I was 12 or 13. I was a cute kid. Okay, so so we already actually talked about the molars and premolars thing, and here's a figure that kind of shows that. And this also shows when those last molars come in. So you get your first additional pair of molars, 6 to 7, your second ages 12 to 13, and your third ages 17 to 21, which means, wait, you're getting new teeth now? Oh, you're getting new teeth now. We call those the wisdom teeth. Now, many of you may have already or may need to get your wisdom teeth removed. And you may wonder, well, why? Why would we ever have to pull teeth out? The problem is, in many people's cases, these wisdom teeth come in at a weird angle. And so it doesn't take too much imagination to understand why that would be problematic as this tooth continues to grow in. It's going to poke and crowd out the rest of your mouth and be problematic. And so a lot of times they do actually remove those because of that. So what I want to do is just take a quick look at the structure of a tooth. And then in part 2 of the screencast, we'll look at oral hygiene and talk about that. So basically, every tooth has this structure. The most outer portion, that white outer portion, is called the enamel. This is the hardest structure in the human body. And so when you think about, crushing a jawbreaker or, almonds or things like that, you can do that because of this really strong, tough enamel. The dentin is this bone-like material in the middle. It's still pretty hard, but not as hard as the enamel. Everything, by the way, that sticks up above the gums is called the crown. Everything that sticks below the gums are the root. In the very center of your tooth, you've got the pulp. This is where the nerves and blood vessels move into the interior of the teeth. This is why your teeth can hurt, because there are, in fact, nerves down there. This is why it bleeds when you lose a tooth as a kid, because there is a blood vessel. There are blood vessels going in there. And then finally, the gums. And the gums, sometimes called the gingiva, their job is to adhere to the tooth, and they prevent bacteria from getting down inside that and accessing the area between your tooth and your gum. So what we're going to do now is we're going to talk about problems in the mouth. So I will pause, and part 2 of this screencast will take care of that for us.